Good evening. Okay, so this is an attempt to educate myself a little bit better on radio, just in general. So I went to Wikipedia and typed in radio frequency, and then I got the article for radio spectrum. So I'm going to read the radio spectrum article and maybe put a few pictures to it. We'll see how it goes. The radio spectrum is the part of the electromagnetic spectrum with frequencies from 30 Hz to 300 GHz. Electromagnetic waves in this frequency range, called radio waves, are extremely widely used in modern technology, particularly in telecommunication. To prevent interference between different users, the generation and transmission of radio waves is strictly regulated by national laws, coordinated by an international body, the International Telecommunication Union. I'm going to open that up, a separate article. Different parts of the radio spectrum are allocated by the ITU for different radio transmission technologies and applications. Some 40 radio communication services are defined in the ITU's radio regulations, RR. In some cases, parts of the radio spectrum are sold or licensed to operators of private radio transmission services. For example, cellular telephone operators or broadcast television stations. Ranges of allocated frequencies are often referred to by their provisioned use. For example, cellular spectrum or television spectrum. Because it is a fixed resource, which is in demand by an increasing number of users, the radio spectrum has become increasingly congested in recent decades, and the need to utilize it more effectively is driving modern telecommunications innovations such as trunked radio systems, spread spectrum, ultra-wideband transmission, frequency reuse, dynamic spectrum management. These are all different definitions that I have no clue what they're about, and I stand to investigate further. Frequency pooling and cognitive radio. Bands. And then it says there's a separate article for broader coverage of this topic. See EM band. That's probably something I'm interested in. A radio band is a small, contiguous section of the radio spectrum frequencies in which channels are usually used or set aside for the same purpose. To prevent interference and allow for efficient use of the radio spectrum, similar services are allocated in bands. For example, broadcasting mobile radio or navigation devices will be allocated in non-overlapping ranges or frequencies. For each of these bands, the ITU has a band plan which dictates how it is to be used and shared to avoid interference and to set protocol for the compatibility of transmitters and receivers. ITU. As a matter of convention, the ITU divides the radio spectrum into 12 bands, each beginning at a wavelength which is a power of 10 meters, with corresponding frequency of 3 times 10 to the 8 Hertz, and each covering a decade of frequency or wavelength. Each of these bands has a traditional name. For example, the term high frequency, HF, designates the wavelength range from 100 to 10 meters, corresponding to a frequency range of 3 MHz to 30 MHz. This is just a naming convention and is not related to allocation. The ITU further divides each band into sub-bands allocated to different uses. Above 300 GHz, the absorption of electromagnetic radiation by Earth's atmosphere is so great that the atmosphere is effectively opaque until it becomes transparent again in the near-infrared and optical window frequency ranges. These ITU radio bands are defined in the ITU Radio Regulations. Article 2, provision number 2.1 states that the radio spectrum shall be subdivided into 9 frequency bands, which shall be designated by progressive whole numbers in accordance with the following table. The table originated with a recommendation of the 4th CCIR meeting held in Bucharest in 1937 and was approved by the International Radio Conference held at Atlantic City, New Jersey in 1947. The idea to give each band a number in which the number is the logarithm of the approximate geometric mean of the upper and lower band limits in Hertz originated with B.C. Fleming Williams, who suggested it in a letter to the editor of Wireless Engineer in 1942. For example, the approximate geometric mean of band 7 is 10 MHz or 10 to the 7 Hz. And there's a chart here. Band name, extremely low frequency, abbreviation ELF. ITU band number 1. Frequency and wavelength 3 to 3 Hz. And then it's got a distance 100,000 to 10,000 kilometers. And example uses, communication with submarines. Super low frequency, abbreviation SLF, ITU band number 2, 3 to 300 Hz, or sorry, 30 to 300 Hz, communication with submarines. Ultra low frequency ULF, submarine communication, communication with mines. Very low frequency VLF, navigation, time signals, submarine communication, wireless heart monitors, geophysics. Low frequency, which is LF, navigation, time signals, AM long wave broadcasting, Europe and parts of Asia, RFID, and amateur radio. So that's 30 to 300 kilohertz. Medium frequency, MF. AM medium wave broadcasts, amateur radio, avalanche beacons. High frequency, which is HF. Shortwave broadcasts, CB radio, amateur radio, over-the-horizon aviation communications, RFID, over-the-horizon radar, automatic link establishment, near-vertical incidence, skywave radio communications. VHF, FM television broadcasts, line of sight to ground aircraft, aircraft to aircraft communication, land mobile, maritime mobile communication, amateur radio, weather radio. Ultra high frequency, UHF, television broadcasts, microwave ovens, microwave devices communication, radio astronomy, mobile phones, wireless LAN, Bluetooth, Zigbee, GPS, a two-way radios such as land mobile, FRS, GMRS, radios, amateur radio, satellite radio, remote control systems, ADSB. Super high frequency, SHF, radio astronomy, microwave devices communications, wireless LAN, DSRC, most modern radars, communication satellites, cable and satellites, television broadcasting, DBS, amateur radio, satellite radio. EHF, extremely high frequency, radio astronomy, high frequency microwave radio relay, microwave remote sensing, amateur radio, directed energy weapon. It's actually on here. Millimeter wave scanner, wireless LAN. Terahertz or tremendously high frequency, THZ or THF, experimental medical imaging to replace X-rays, ultrafast molecular dynamics, condensed matter physics. Terahertz, time domain spectroscopy, terahertz, computing, communications, remote sensing. Okay, further down the page, there's broadcasting, the applications section. Broadcasting, and the main article is radio broadcasting. Broadcasting frequencies, long wave AM radio, which is 148.5 kilohertz to 283.5 kilohertz. Medium AM radio, 525 to 1710 kilohertz. Shortwave AM radio, 3 megahertz to 30 megahertz. Designations for television and FM radio broadcast frequencies vary between countries. See television channel frequencies and FM broadcast band. Since VHF and UHF frequencies are desirable for many uses in urban areas in North America, some parts of the former television broadcasting band have been reassigned to cellular phones and various land mobile communications systems. Even within the allocation still dedicated to television, TV band devices use channels without local broadcasters. The Apex band in the United States was a pre-World War II allocation for VHF audio broadcasting. It was made obsolete after the introduction of FM broadcasting. Airband. Airband refers to VHF frequencies 118 to 137 megahertz used for navigation and voice communication with aircraft. Transoceanic aircraft also carry HF radio and satellite transceivers. Marine band. The greatest incentive for development of radio was the need to communicate with ships out of visual range of shore. From the very early days of radio, large ocean-going vessels carried powerful long-wave and medium-wave transmitters. High-frequency allocations are still designated for ships, although satellite systems have taken over some of the safety applications previously served by 500 kHz and other frequencies to 2182 kHz is a medium-wave frequency still used for marine emergency communication. Marine VHF radio is used in coastal waters and relatively short-range communication between vessels and to shore stations. Radios are channelized with different channels used for different purposes. Marine channel 16 is used for calling and emergencies. Amateur radio frequencies. Amateur radio frequency allocations vary around the world. Several bands are common for amateurs worldwide, usually in the HF part of the spectrum. Other bands are national or regional allocations only due to differing allocations for other services, especially in the VHF and UHF parts of the radio spectrum. Citizens band and personal radio services. Citizens band radio is allocated in many countries using channelized radios in the upper HF part of the spectrum, around 27 MHz. It is used for personal, small business, and hobby purposes. Other frequency allocations are used for similar services in different jurisdictions. For example, UHF-CB is allocated in Australia. A wide range of personal radio services exist around the world, usually emphasizing short-range communication between individuals for small businesses, simplified or no license requirements, and usually FM transceivers using around 1 watt or less. Industrial, scientific, medical. The ISM bands were initially reserved for non-communications uses of RF energy, such as microwave ovens, radio frequency heating, and similar purposes. However, in recent years, the largest use of these bands has been by short-range, low-power communication systems using systems since users do not have to hold a radio operator's license. Cordless telephones, wireless computer networks, wireless computer networks, Bluetooth devices, and garage door openers all use the ISM bands. ISM devices do not have regulatory protection against interference from other users of the band. Land mobile bands. Bands of frequencies, especially in the VHF and UHF parts of the spectrum, are allocated for communications between fixed base stations and land mobile, vehicle-mounted or portable transceivers. In the United States, these services are informally known as business band radio. See also professional mobile radio. Police radio and other public safety services such as fire departments and ambulances are generally found in the VHF and UHF parts of the spectrum. Trunking systems are often used to make most efficient use of the limited number of frequencies available. The demand for mobile telephone service has led to large blocks of radio spectrum allocated for cellular frequencies. Radio control. Reliable radio control uses bands dedicated to the purpose. Radio-controlled toys may use portions of unlicensed spectrum in the 27 MHz or 49 MHz band, but more costly aircraft, boat, or vehicle models use dedicated radio control frequencies near 72 MHz to avoid interference by unlicensed users. The 21st century has seen a move to 2.4 GHz spread spectrum RC control systems. Licensed amateur radio operators use portions of the 6-meter band in North America. Industrial remote control of cranes or railway locomotives use assigned frequencies that vary by area. Radar. Radar applications use relatively high power pulse transmitters and sensitive receivers, so radar is operated on bands not used for other purposes. Most radar bands are in the microwave part of the spectrum, although certain important applications for meteorology make use of powerful transmitters in the UHF band. Radio waves are a type of electromagnetic radiation with wavelengths in the electromagnetic spectrum longer than infrared light. Radio waves have frequencies as high as 300 GHz to as low as 3 kHz, though some definitions describe waves above 1 or 3 GHz as microwaves, or include waves of any lower frequency. At 300 GHz, the corresponding wavelength is 1 millimeter, and at 3 kHz is 100 kilometers, 62 miles. Like all other electromagnetic waves, they travel at the speed of light. Naturally occurring radio waves are generated by lightning or by astronomical objects. Artificially generated radio waves are used for fixed and mobile radio communication, broadcasting, radar, and other navigation systems. Communications, satellites, computer networks, and innumerable other applications. Radio waves are generated by radio transmitters and received by radio receivers. Different frequencies of radio waves have different propagation characteristics in the Earth's atmosphere. Long waves can diffract around obstacles like mountains and follow the contour of the Earth. Ground waves, shorter waves, can reflect off the ionosphere and return to Earth beyond the horizon, sky waves, while much shorter wavelengths bend or diffract very little and travel on a line of sight, so their propagation distances are limited to the visual horizon. To prevent interference between different users, the artificial generation and use of radio waves is strictly regulated by law, coordinated by an international body called the International Telecommunications Union, which defines radio waves as electromagnetic waves of frequencies arbitrarily lower than 3,000 GHz propagated in space without artificial guide. The radio spectrum is divided into a number of radio bands on the basis of frequency allocated to different uses.